So today we're going to be doing proofs, and proofs are kind of tricky because it's like solving a puzzle. You'll see an equal sign, but it's not actually an equal sign. You're proving that they are equal. And so there are some strategies that we're going to be writing down to help you along with this process. So the first thing that you need to write down is that you only work on one side of the equal sign. It's not an equation. So I can't move things from the left to the right, right to the left like I usually do, because it is not proven yet that they are equal, and so you can't move things across the equal sign. And so what you can do is you can work on the left-hand side, and you can see if it gets you to the right-hand side, and if not, you can start on the right-hand side. So the second strategy is to keep in mind your end goal, so whatever you're trying to get to. The third one that we're going to be using for the first problem is to change things in terms of sine and cosine. And so you're going to be using the identities that we learned yesterday, and you're going to be using those, and a lot of those get to sine or cosine. And so if you can get things in terms of that, you have more options. And so if we're looking at the first one, I'm going to put my line down through the equal sign. You can only choose to work on the left side or the right side. And so I always try to do the left side first. And our end goal right here is to get cotangent. We're trying to figure out how we can get cosine cosecant to equal cotangent. And so I'm going to change things and turn in sine and cosine. So this cosine right here is already in terms of sine and cosine. So I'm just going to recopy that down. But this cosecant, it is not in terms of sine and cosine. So I'm going to go to my identities, and now I'm going to figure out where would cosecant, how could I change that into sine and cosine? So cosecant, the first time I see cosecant is right here. Cosecant equals 1 over sine. And so that puts it in terms of sine and cosine. So I'm going to change that to 1 over sine. So that's my first step. So then the next thing I'm going to do is I'm going to actually just simplify this up. Cosine times 1 over sine is cosine over sine. So I just scooted the cosine up top. And this is where you need to keep in mind your end goal, because cosine over sine, if we would look at our identities right here, cosine over sine is cotangent, and that was our end goal, was cotangent. And so it's good to get familiar with these identities here, because if you know, like I know that cosine over sine equals cotangent, and so that a little red bell would go off in my head when I saw step 2. Oh, that's an identity. Cosine over sine is cotangent. So it worked out. This is very reliant on work. If you just write a bunch of identities and put a check mark next to it, I'm not going to mark it right unless I can follow logically where you're going. So number 2. So my end goal is to get 1. So I only work on one side of the equation, so I'm going to look at the left-hand side first. I'm going to get things in terms of sine and cosine. So these things are squared, and that's fine. So 1 over cosine, or cosecant squared. So I look for 1 over cosecant. And 1 over cosecant is right here. It equals sine. But since it is cosecant squared, it just means that 1 over cosecant squared will equal sine squared. So I'm going to change that to sine squared. So that, using my Pythagorean, or my reciprocal identities, is sine squared. So then 1 over secant squared. So 1 over secant is right here. So 1 over secant squared would be cosine squared. So I'm going to change that. So now I've gotten everything in terms of sine and cosine. And so the last hint is to look for Pythagorean identities. So if you see things with a plus or minus sign and you see things that are squared, there's a good chance that it is a Pythagorean identity. And sine squared plus cosine squared is a Pythagorean identity. It's right here. Sine squared plus cosine squared equals 1. And that is my end goal. That equals 1. And so it checked out. So number 3, right off the bat on top, everything on top and bottom is sine and cosine. But up top, that is sending a little red blinker in my head. 1 minus sine squared is a Pythagorean identity. So 1 minus sine squared is right here. 1 minus sine squared is cosine squared. So I'm going to change the top of this to cosine squared. I'm going to keep the bottom the same. And my end goal is cotangent squared. And so another little red blinker is going off in my head. Cosine over sine is an identity. Cosine over sine is cotangent. Both of them are squared, so cosine squared over sine squared would equal cotangent squared. Which was my end goal, so I am done. So then the last three. So I have tangent plus cotangent. So I'm going to change both of those in terms of sine and cosine first. So tangent right here equals 1 over cotangent. But that's not in terms of sine and cosine. You're not going to use this one as much as the quotient identities. So tangent equals sine over cosine using the quotient identity. So I'm going to use that choice instead of this one because it has sine and cosine in it. So I'm going to change my tangent to sine over cosine. Okay, then cotangent. Cotangent, I again would not use this one because that changes it to tangent, but I would instead use this one because it changes it to cosine and sine. So cotangent is cosine over sine. So now that everything is in terms of sine and cosine, I don't see any Pythagorean theorems yet because there's no squares. So the last suggestion is don't forget your algebra. Sometimes you'll need to find a common denominator, sometimes you'll need to factor, and sometimes you'll need to keep change flip. In this case, since I have two fractions being added, I need to find a common denominator. And so what I'm going to do to find my common denominator is I just bring both of them down as part of my LCD. So my LCD will be cosine, sine. So to get cosine sine, this one, the first fraction has the cosine, it needs the sine. So that means the top of that one's going to be sine squared. The second one has the sine, it needs the cosine. So that is going to be cosine squared. So in this second step, you should have a little red blinker going off in your head because now I have things that are squared and added. Sine squared plus cosine squared using the Pythagorean identity is 1. I'm going to move over here. So the top is now 1, and the bottom is going to stay the same. And so my end goal is secant, cosecant. So I've gotten rid of the plus, so I'm getting there, which is good. And so to get secant and cosecant, you have to look at this as two separate things, 1 over cosine and 1 over sine. So 1 over cosine, using the reciprocal identity, is secant. And then 1 over sine is cosecant using the reciprocal identity. And so that checks out. The next one. On top right away, I see a Pythagorean identity. 1 plus tangent. 1 plus tangent. Tangent plus 1, doesn't matter if the order is different, is secant squared. So I'm going to change the top of that to secant squared. And I'm going to keep it over cosecant squared. And so now I'm going to change things in terms of sine and cosine. I've gotten rid of the plus, which is good because my end goal doesn't have a plus in it. And so secant squared, if I change that in terms of sine and cosine, secant equals 1 over cosine. So I'm going to change that to 1 over cosine. It'll be squared because the secant's squared. And this is all over cosecant squared. So cosecant equals 1 over sine. So I'm going to change that to 1 over sine squared. So that's my second step. Now I have a fraction on top of a fraction, so I need to use some algebra to clean this up. I need to keep change flip. So I'm going to keep the top fraction the same. And I'm going to flip over the bottom fraction, so it'll be sine squared over 1. So then I'm going to just clean it up a bit. I'm going to multiply them together, so I'm going to do 1 times sine squared up top, which is sine squared, and on bottom, cosine squared times 1 is cosine squared. Again, my end goal is tangent squared, and the little red blinker should go off in your head. Sine squared over cosine squared is an identity. That is tangent. Since everything's squared, it'd be tangent squared. So tangent squared it is. Alright, the last one. So for this one, let me erase this stuff so that we can work. Alright, so on the top I have cosine squared. On the bottom it looks like a Pythagorean theorem, but it isn't because there's no squared. And so for this one, if I look at my end goal, everything's in terms of sine. And so what I'm going to do is I'm going to change that cosine squared in terms of sine. If I go to my Pythagorean identity, cosine squared equals 1 minus sine squared. So what I'm going to do is change that cosine on the top to 1 minus sine squared. So that cosine is going to become 1 minus sine squared. I'm going to keep the bottom the same. And now this is a hard one to see, so I'm not going to give anything this hard, but the top 1 minus sine squared, that is a difference of two squares. And so what I'm going to do is I'm going to be doing the factoring formula. So we square root both of them. The a will be 1, and the b, I'm going to square root the sine squared and get sine. So I plug it in, a minus b, a plus b, and I still have my bottom the same. And the reason I do that is because my end goal is just 1 plus sine theta, so I can cross out those, and I'm left with 1 plus sine theta, which is my end goal.